Today I will teach about one of the chapter of S2 complementary course. The chapter is sequence of real numbers. So what is a sequence? All of you know about sequence. I think all of you heard, all of you learned in school days about sequence. What is a sequence? Sequence is some collection of objects and repetition are possible. Any collection of objects we can say sequence. Roughly we can say sequence. It is not a mathematical way, but it is roughly we can say sequence is a collection of objects and repetition allowed. So sequence, set of numbers, number sequence is possible. One of the type of sequence. Alphabetic sequence is another kind of sequence, etc. So we can form a lot of sequence. But in this section, in this chapter, we will discuss about sequence of real numbers. Obviously, we know here we studied mathematics. So here we studied mathematics sequence or sequence of numbers. In this chapter, specifically I will say in this chapter we will study the sequence of real numbers. So sequence means we have some objects or some numbers. That collection of numbers we can say first object, second object, third object, 10th object, 100th object. That is the main thing about the sequence. The concept of sequence involves not only numbers but also objects also. And second thing is the sequence is connected with natural numbers, because we can say first object. What is a first object? What is a 10th object? What is an nth object? That's why we can say the sequence is connected with the natural numbers. Next, I will say the mathematical definition of sequence. In the mathematical way, sequence is a function. Sequence is a function. Its domain is a natural number set and range set is a real number set. That means sequence is a function from set of natural number to set of real numbers. So any natural number we can take corresponding a sequence in a R, real number set. That means any natural number n we will take from capital N corresponding some an in capital R. That means set of real numbers. So f of n equal to an. This an, collection of an is called sequence. So f of 1 means a1. F of 2 means a2. F of 3 means a3, etc. F of n means an. So we can take a1, a2, etc. This collection is called sequence. Sequence of real numbers. Once more I will say, sequence is a function from set of natural number set to set of real number set. So in a natural number there is a corresponding any natural number corresponding to real number. That real number, set of real numbers or set of images is called sequence. Image of natural number set or positive integer. We can take positive integers also. That means 0 included. Image set of this function is called sequence. And image of nth term, image of n is called nth term of sequence. Image of n means that term is an. So an is an nth term of sequence. So first term is a1, second term is a2, 10th term is a10, nth term is an. So these collections, the image set of images in this function is called sequence. So next is recursive method. We can write down the sequence two ways. One of the way is all of the terms we can write down in the set. So we have first term, second term, third term, etc. 1000 terms in that sequence. Means we write it as 1000 terms. So that is the difficult way. So we can apply the common, we will say the first term, what is a first term, and continuing some pattern, some common property in that sequence. In that sequence have a common property. So we will say in that property. That way is called, that way we will see in the sequence is called recursive sequence, recursive way of sequence presentation. Once more I will say, in the sequence, we have a sequence. That sequence we can present in two ways. One is we can write it as all terms in the sequence. The other way is we choose the first term and repeatedly applying the same process to each term to arrive at the following terms. So we have a common, in that sequence have a common property. So we find it out that property and we will say, so we can say nth term an, we will get an minus 1 plus 1. This is the recursive method. Otherwise an we will get 1 by n. So this is the common property of all of the sequence. So that is called recursive method of presenting sequence. Recursive method. Next I will say some examples. Let I defined a function from natural number set to real number set. That function is a of n equal to n. So we got a1 equal to 1, a2 equal to 2, a3 equal to 3, a4 equal to 4. That means the sequence is 1, 2, 3, 4, 5, etc. So, what is the general property? So, we fixed the first term is 1. So, a1 is 1. And a2 is 1 plus 1. a3 is a2 plus 1. a4 is a3 plus 1. So, we can generally say an is an minus 1 plus 1. That means a2 is a1 plus 1. a3 is a2 plus 1. a4 is a3 plus 1. Is it right? So generally we can say an is next near to back sequence plus 1. So the back sequence, near back sequence is a sequence term is an minus 1 plus 1. So this is the recursive representation of sequence, and the sequence is this one. Terms of the sequence is this. So these are the terms of sequence. First term is 1, second term is 2, third term is 3, and nth term is n. So we can recursively we can write it as an equal to an minus 1 plus 1. Similarly, second example, similarly I defined a function from natural number set to R and an equal to 2n. So we got a1 is 2, a2 is 4, a3 is 6, a4 is 8. So an is 2n. So we can say our sequence is 2, 4, 6, 8, etc. So recursively we can write it as an equal to an minus 1 plus 2. Next example is, so I will define a constant sequence. So I defined a function n to r, an equal to some 1. I defined some 1. So first term is 1, second term is 1, etc. Nth term is also 1. Not ending, we can continue to infinity. So in this sequence we have 1, 1, 1, 1, 1, 1 sequence. So recursively we can write an equal to 1 for all. This is the sequence and terms are 1, 1, 1, 1. Next example is, I defined a function n to r, an is n plus 1 if n odd and n minus 1 if n even. So A1 is 2, A2 is 0, A3 is 4, A2 is 2 minus 1, 1, sorry, A2 is 1, A4 is 4 minus 1, 3, A5 is 6. So in this defined sequence is 2, 1, 4, 3, 6, etc. This is the another sequence. One of the famous mathematical sequence is Fibonacci sequence. I think all of you heard. Fibonacci sequence is a one of the important sequence in the mathematics. We can see in the nature, we can see Fibonacci sequence. In the sunflower, we can see Fibonacci sequence. A lot of applications we can see in the nature. That I will say later. In this section I will explain what is the Fibonacci sequence. So first term A1 is 1, A2 is also 1, A3 is 2, A4 is 3, A5 is 5, A6 is 8. Have any connections? You got it? We have 1, 1, 2, 3, 5, 8. Next term, what is the next term? 13. Next 21, etc. This sequence is called Fibonacci sequence. So recursively we can write A1 is 1. A1 we fixed 1. And A2 is A1 plus 0. A3 is A2 plus 1. A2 plus 1. A2 plus 1. A4 is A2 plus 1 means A2 plus A1. A2 is A1 plus 0. A3 is A2 plus A1. A4 is A3 plus A2. So A5 is, so here A1, A2, A3, A4, A5. A5 is A4 plus A3. A6 is A1, A2, A3, A4, A5, A6. A5 plus A4. Continuing, An is An minus 1 plus An minus 2. So this is the terms of Fibonacci sequence, and recursively we can write it as An equal to An minus 1 plus An minus 2. So I think all of you understand what is a sequence and what are the examples of sequence. Next is limit of sequence.